All right, in this video, we're going to be talking about absolute value equations. So first, let's read through some of these. So steps to solve this. So when you're solving this, you should be thinking kind of like when you're solving equations, but then there's a little bit different things. So first, we have to make sure the absolute value expression is isolated, so by itself. We have to set the inside, so whatever is inside the absolute value signs, equal to both the positive and negative number on the other side of the equation. So remember, the absolute value measures distance. So if I said the absolute value of -9, well, really that is 9 units away from 0. So both 9 and -9 work. So that's why we set it both to positive and negative. And then we're going to solve both equations. So we're going to end up with possibly 2 answers, sometimes only 1, sometimes we don't end up with any, but it just depends. And then we're going to write our answer as a solution set. So we've seen these curly brackets before. We just are listing them in curly brackets. So let's move right along. We're not going to do all of these problems, but we are going to do some. So number 1, there is nothing by the absolute value signs. So I can say it's isolated. And I'm going to set it equal to both the positive 2 and the negative 2. So we always need to kind of like set that up and then solve. So because there's nothing else left in the absolute value sign, I can drop it. And I would have the answers 2 and -2. So my solutions would be, remember, least to greatest, -2, 2. But if we have something like number 4, so number 4, there's nothing on the outside of the absolute value sign. So I can say it's isolated. And again, I'm going to set the inside equal to both the positive and the negative. There is nothing else for me to do on the inside. I'm going to drop my absolute value signs and solve. So here I'm going to divide both sides by -7. And I'm going to get A equals a -4 and A equals +4. Number 5, same thing. There's nothing on the outside, so it's isolated. Set both, or set the inside equal to a positive and a negative. I made that the absolute value sign. I cannot combine D and 1 on the inside, so there's nothing else left for me to do except drop them. Drop the absolute value signs. And then solve for D, so subtract 1 on both sides. These ones cancel, and I'm left with D equals 7. Oh, I forgot. On number 4, I forgot to go back and write them as a solution set. And then D equals -9. So my solution set would be -9, +7. For number 7, same thing. There's nothing on the outside of the absolute value signs. So I can set the inside to a positive and a negative. I cannot combine 4n and 2, so I can drop them. drop the absolute value signs, and solve. So I need to get n by itself, but I need to get rid of the 2 first. So I have 4n equals 32 and 4n equals negative 36. Divide both by 4. I have n equals positive 8 and n equals negative 9. So my solution set would be negative 9, positive 8. Hopefully this is making sense so far. It's just like solving equations, but again with a twist. If there's stuff outside of the absolute bars, we need to isolate the absolute value. So to do that, we would solve this as if the absolute value and whatever's inside is like our variable that we're trying to solve for. We're going to leave it alone for a second. So for number 9, to get the absolute value by itself, I would get rid of 2 by subtracting it to the other side. Now that the absolute value is by itself, I could continue on with what I was doing before, set the absolute value to both a positive and a negative of that number. There's nothing else left for me to do on the inside, so I can drop the absolute value signs. And my solution set would be negative 10, positive 10. For number 12, I know before we talked about the absolute value signs as like parentheses. However, you're not going to distribute here. If I want to isolate the absolute values in 12, I need to get rid of that negative 2. Remember that any two things next to one another are multiplying. So to get rid of it, I would divide both sides by negative 2. The negative 2's are going to cancel, just leaving the absolute value signs. This becomes a positive 7. So now that we have isolated the absolute value, I can set this inside equal to a negative 7. And since I cannot do anything on the inside, I can drop the absolute value signs. And solve. So I need to get z by itself on both sides, so subtract 3. So z equals 4 and z equals negative 10. So my solution set would be negative 10, 4. For number 13, it's kind of like 12, but it looks a little different because it's in a fraction form. Again, I need to get rid of the 6, so I'm going to multiply this entire side by 6 and do the same thing on this side. These 6's are going to cancel, just leaving the absolute value signs and 18. From there, all the work is the same. So we have 2w minus 4 equals 18 and negative 18. I'm trying to get w by itself, so I would add 4 to the other side. So we have 22 and negative 14. Divide both sides by 2. So we have W equals 11 and W equals negative 7. So our solution set would be negative 7, 11. Number 14 looks a little complex because it has a number right outside and something else, but it's really the same. We need to get rid of both negative 10 and negative 3. I would say get rid of the negative 3 first, because if you try to get rid of the negative 10 first, you would need to multiply both sides by negative 10, and then you end up with bigger numbers than you really want. So let's add 3 to both sides. It gives us negative 80. I'm sorry, not multiply. When I said earlier, I meant divide. And then you end up with fractions that you don't want. Here, to get rid of negative 10, I'm going to divide both sides by negative 10. So we have the absolute value of h plus 5 equals 8. Now that we've isolated the absolute value, everything else is the same. To get h by itself, we would need to subtract 5 on both sides. So we have h equals 3 and h equals negative 13. So our solution set would be negative 13 and 3. $15 is very similar. 16 is also very similar. It just has that fraction. Don't let that fraction throw you off. Now we're going to move on to some special cases. So for 17, because this equals a negative number, it's isolated, we haven't done anything else, this is going to be a no solution. Or you can do the line with the circle. Because we cannot solve equations or absolute value equations that start this way. Now, I know you're probably thinking, but don't we always do that? Don't we always set it to a negative? Yes, we set it to a negative number. It doesn't start with a negative number. So if it starts with a negative number, or we isolate the absolute value and it's a negative number on the side, we can't solve it. So for 18, I'm going to isolate it by dividing both sides by a negative 3. And again, I have that it equals a negative number. So I cannot solve this because it equals a negative number. So I'm going to go into the explanation part. So the absolute value cannot equal a negative number once isolated, which is really what I said, but we can set it equal to a negative number because it does equal a negative number, but it can't start off with a negative. Just like when you're simplifying, it can't be negative. It's kind of the same thing. So we're going to do one more example, and these are really special kinds that you may see on like Khan Academy if you're practicing, things like that. So we're going to do this one on the left. Now, you'll see that these have absolute value signs on both sides, which is not something that was in the notes. But to do this, we're kind of using the same rules with a twist. I know everything is with a twist. All right, so the very first thing we're going to do is move all the absolute value signs to the same side. Does not matter whether you move the negative 2 times absolute value of x minus 14 to the right, or the negative 6 times the absolute value, x minus 14 to the left. I am going to move to the left, and I'm going to, so still think solving equations. I'm doing the opposite. And I'm adding this over here. Right? So think about these as like terms. Think about everything inside the absolute value as your value or your variable x, or you could pick a different one. Because these have the same, I'm quoting, variable, I can combine these two. So negative 2 plus 6 would give me a positive 4. When I combine like terms, I just keep one of them, so that would also happen here. And I still have that minus 1 on the other side, so that just gets brought down. Now, this looks like something we've been doing. It doesn't look as complex. So I need to isolate the absolute value by subtracting by 5. I end up with negative 6. Then divide both sides by 4. I can simplify this. It would be negative 3 over 2. However, we cannot solve absolute value signs that have a negative, so this would be no solution. Does not have any, we cannot go further. Now, just to show you that the same thing would have worked on the other side, I'm going to rewrite this. Actually, instead of doing that, I'm going to do this. Yeah. And now instead of moving 6 over, I'm going to move the 2 over. So when I do that, these 2's cancel, just like these 6's cancel. I just didn't put that. I'm left with 5 on one side equals, I have negative 4 when I combine these two. Think about the x minus 14 as like terms. My absolute value sign, x minus 14. And then my minus 1 at the end. Now I'm going to solve this like I would any other. So I would add 1 to both sides. I know right now you're probably thinking, well, it's going to get a positive, so it's not going to be the same. But hold on. So it's almost isolated. I now need to divide both sides by negative 4. Oh, there's that negative. So we still get that negative 3/2. Which means this is still no solution. You will now have time to practice. Let me know if you have any questions.